Okay, this is the solving triangle problems exercise. It's an exercise 9E. There's no new learning here as such. It's just putting together everything that you know or have learnt so far in order to solve a problem. This is question 15 from 9E. I'm going to go through the methods that I would use to solve the problem. I haven't done this one yet, and I've no doubt that you will all come across different ways of doing it. And it's possible that in the answers in the back, if they do show any work and that they've done it differently. But I'm going to go through from scratch how I would solve this problem. You're told you have a square, side 10. So I can write on some more values that I know. We're told that angle CED, this angle here, is obtuse. So I'm going to assume that I need to find out what that angle is. Anything else I can write down? Yes, I can. I can write down straight away. Well, this angle is, it's a square, so this is a right angle, that's 40. So that is 50 degrees. Well, I've got two sides here. I've got an angle, I want to find the other angle. I think I can work that angle out pretty quickly. I'm going to assume I need to. I can't see quite yet how working out that angle will help me work out the area of this triangle, which is what the question is asking me, but let's go with that anyway. I've got two sides, I'm dealing with two angles. That angle is opposite that side, that angle is opposite that side, so this just looks like sine rule straight off. So I'm finding angle E, so let's write down what I'm doing. I'm going to find angle E. And because I'm finding an angle, I'm going to use the sine rule. Sine A over A equals sine B over B. I'm going to use it with the angle on the top because that's what I'm finding. So let's put my values in. Sine E, that's the angle I want, divided by 10 is sine 50 over 8. Rearranging gives me sine E is 10 sine 50 divided by 8. So sine E equals, pressing the buttons on my calculator, 10 times sine 50, close my brackets, divided by 8 equals 0.95755. Better round off at that point, but I'm leaving that on my calculator. So E is therefore, shift sine, answer equals 73.2 degrees, but it tells me that angle E or angle CED is obtuse, so I need to find the alternative one. And as we've seen before, to find the alternative angle, the obtuse angle, if we've got the acute angle for sine, then if I do 180, take away my primary, then E is 106.8. We'll round it up to one decimal place. So E is 106.8. So I know that angle. If I'm finding this triangle here, I'm either going to use half AB sine C, in which case I need two sides. I've already got one side. I could find the other side, then try and find this angle, which would be the angle in between those two sides. I have a feeling here it might be easier to use the sort of year 8-9 version of the area of a triangle. If I can work out this distance here, take it from 10, that'll give me this distance here. So I have the base and I have the height of this triangle. I'm going to do it that way. Yes, I'm going to do it that way. So ideally I want this height here. I can work out this angle because if that's 106.8, that's 50. So these two are 156.8 take from 180. 180 take away 156.8. This means this angle is 23.2. I may or may not need all this information. I'm just writing down all the information that I've gathered so far. To work out this height, I know the hypotenuse, I know that angle. I could just use a little bit of trigonometry. So let's work out the height of triangle CDE. So I want this length here. That's an opposite to that angle. That's the hypotenuse. So therefore sine of 23.2 is opposite over hypotenuse. So height is therefore 8 times sine 23.2 degrees. The height is therefore 8 times sine 23.2, which is 3.15 centimeters. So x is 3.15 centimeters. So therefore the height of triangle ABE is 10 take away 3.15, which is 6.85. So I now know the height of ABE is 6.85. I know the base, so therefore I can work out the area. So area of ABE is half the base times the height, which is half times 10 times 6.85, which is 0.5 times 10 times 6.85 is 34.25 square centimeters. Just looking briefly at that, does that make sense? The area of the whole thing is 100, so this is just over a third. That could easily be just over a third, also given it's not to scale, but it looks the right kind of number. So the methods I've used are just to utilize, in this particular case, area of a triangle, bit of trigonometry, and the sine rule in order to get the information I need. As I was going through, all I was doing is figuring out what I might want to need, what information I might need, and then using the strategies I have in order to get that information. You could have done it by working out this angle, working out that angle, working out that side, by playing around with this triangle a little bit more. That would have been another way of doing it, perfectly valid way of doing it. It might have been useful then to work out this length rather than that length. But there would have been all sorts of methods. Each method should have given you the same final answer.